Hey guys, hope all are fine. So we will see a simple inductor circuit. Okay, we will study the working of inductor by studying two circuits. One is inductor in series with an LED and another one is inductor in parallel with an LED. Okay, so first let us draw the circuit. So I'm having a 9-volt supply which is a battery. Okay, and a resistor of 1K to resist the flow of current to the LED, and then an inductor in series with an LED. This is a 5 mm LED. Okay, so this is an inductor. So this is a series circuit. Okay, so we are going to see the working with series and parallel circuit. The same 9-volt supply and 1K resistor to resist the flow of current and an inductor in parallel with an LED. Okay, so we can draw this circuit a bit. This parallel circuit can be drawn like this also. Okay, so this is 9-volt. Okay, and this is an inductor and this is your LED. Fine. Now see, generally an inductor, initially the resistance of an inductor will be high, very high. Okay, the resistance of an inductor will be high, very high, which means no current will flow. As the current from the battery starts to flow through this inductor, slowly a magnetic field will be built around this inductor. So this is the working of inductor. See, usually what will happen, whenever a current is flowing through an inductor, the magnetic field around this inductor will be increased. Okay, which means the energy will be stored in the magnetic field. That is the working of inductor. So as the higher the current, the stronger will be the magnetic field. So initially the current resistance will be very high, so that the current will easily, will not pass. As the current increases, automatically the magnetic field increases and the resistance will be less and current will be flowing through this LED. Okay, this is because usually this inductor will opposes the change in current. Okay, so since the current is resistance value decreases, the current will easily flow and your LED will glow. Whereas in this circuit, what happens, initially the current will flow through this. Okay, so what happens, initially since the resistance is high, current will not flow through this inductor because the resistance is very high, whereas the current will flow through this LED. But as the current increases, the resistance of this inductor will reduce. Since the resistance of the inductor will reduce, most of this will behave like just a wire. Okay, see, if there is no resistance at all, easily all the current will flow through it, isn't it? So all the current from this battery will flow through this inductor, so that this behaves like a short circuit. Okay, so since there is no resistor, there is no resistance in this inductor, all the current will be flowing through this inductor. Okay, and it will reach your negative. So this will act as a short circuit and no current will flow through this LED. So when you connect an inductor across, in parallel to your LED will not glow. Of course, this when you switch off the supply, the energy stored in the inductor will be dissipated through this LED and your LED will glow. But the amount, how long your LED glows depends upon the energy stored. Okay, the higher the energy stored, the longer the LED glows. The lesser the energy stored, the lesser time the LED glows. Okay, that's it. But practically, if you see, we cannot see it through eye. Okay, so I'll show you a practical circuit also. So when you connect in series, initially the resistance will be high, the current will not flow, but as the current increases, magnetic field increases and the resistance decreases and current will flow and this LED will glow. Whereas here, since initially the resistance is high, current will not flow through this, whereas current will flow through this. Okay, this through the LED. But as the current increases, the resistance decreases to its very low value, almost zero, so that this will act as a wire, simply wire. So there is no resistance at all the current will be flowing through this, so that this acts as a short circuit and your LED will not glow. Okay,
So
let us check the circuit practically. So this is a 9 volt battery. Okay, so of course we don't have 9 volt now. The voltage will be lesser because I have been using this for a longer time. Okay, so connect the positive to any one point. Connect a 1k resistor. This is an 1k resistor. Okay, connect a 1k resistor, and in series we are going to connect an inductor. So this is an inductor. Okay, so we can't check the value of this inductor with this multimeter. Okay, you need an LCR meter, so we can check the value of inductor whether it is working or not only with an LCR meter. Okay, but this is just an ordinary multimeter, you cannot check it, but this is working. Okay, so connect an inductor in series and then connect a LED. Okay, so everything is in series. Now connect the ground. The moment you connect your ground, your LED will glow. Okay, because the inductor is connected in series. Initially the resistance will be high, but as the current increases, your magnetic field will increase and the resistance uh, across this inductor will be reduced very less. So the current will pass and your LED is glowing. Okay, so the same circuit, when I connect it in parallel, so before that we will check what is the current flowing through this. Okay, so check, set the multimeter to milliamps. Okay, and then check the current. So almost 0.39 milliamps is flowing. Which is very less. Okay, maybe it depends upon the resistance value, and we are given an 1k resistor. Okay, and now we are going to connect this LED and this inductor in parallel and check whether it is working or not. Okay, so for that, so parallel connection in the sense both this anode and this inductor point should be in the connected in the same point. Okay, so I am just using this point. So from one end of the resistor I have connected an inductor, and the inductor other end I have connected to the ground pin. Okay, and this from the same inductor one end, other end should be connected to the ground. Okay, so this is a parallel connection. I have connected the ground here. So as you can see, the inductor is not, the LED is not glowing because this inductor, it is connected in parallel. The current, like almost all the current will be flowing through this inductor, so no current is flowing through this LED, so this LED is not glowing. Okay, so always remember this point, that is the resistance. So whenever you are using this inductor in a circuit, so you have to decide whether you have to connect this in series or parallel. Okay.